Hello everyone, welcome to session 2, Science, Physics, Light. So in the previous class regarding the introduction for light, we had discussed regarding the basic properties of light, which were very important. So among them, before that we discussed regarding the theoretical background of light by discussing three theories, one given by Newton's corpuscular theory, Huygens wave theory, and the quantum theory given by Planck. So, according to the theories, we still do not know what is the exact nature of light, but light exhibit the properties of both the particle nature and the wave nature at times. So, this is very important concept, you have to keep it in your mind. So, if you treat that light is in the form of particles, that is corpuscles, we can understand the three concepts, that is we can satisfactorily explain the three properties of light, that is reflection, refraction and photoelectric effect, including how the shadows are formed. So if you consider that light is in the form of waves, we can satisfactorily explain the interference, diffraction and polarization. So according to Max Planck, the light exhibits the properties of both wave nature and particle nature. So whichever the particular property of light you are studying, you have to keep that in your mind, that light is also particles, light is also wave nature. So it is dual in nature. So this was the theoretical background. So in today's session, session 2 of physics, we will be going with the first very important property of light, that is reflection. So it's a very important concept. So here, usually in our day-to-day life, we come across reflection. So what is that actually? When we stand in front of a mirror, we see our own image. When we see the surface of the still water, we can see our image. When we stand in front of highly polished metallic surfaces, we are going to see our own image. But at the same time, when we stand in front of a wall, or when we stand in front of a wood, or when we stand in front of a sheet of paper, or we stand in front of a cloth, we cannot see our images. So what is the reason behind this? So the concept is, whenever the light rays coming from the source of light means sun, it may be sunlight, it may be the light coming from a bulb, or it may be the light rays coming from a candle light, it can be the light coming from a red hot iron, whatever it is. So the object which gives out its own light is called as the luminous object, what we have understood in our previous class. So when the source of light gives out light rays, and these light rays when fall on different objects around us, we are able to see the objects. So if these objects are not reflecting the rays, then we will not be able to see the objects. So where does a 100% very good reflection takes place? So before that, let us understand the definition of reflection. So whenever light rays are made to fall on a surface, most of the light rays get reflected. So if, for example, if you take a ball and throw it to the wall is going to send back the ball or bounce back the ball back to your hands. In the same manner, when the light rays are made to fall on a metallic surface or a smooth surface or a highly polished surface, the light rays are going to get reflected. So this phenomena, this property of light is known as reflection of light. So where does a good reflection happens? So a good reflection happens when the light falls on a smooth, highly polished, bright surfaces. Then a beautiful reflection happens. So what happens when light falls on a wood or paper or a wall, right? So here what happens is, there also reflection takes place, but the reflected light rays are spread in all different possible directions. So we are inside a room. For example, at the corner of the room there is a chair. When we put on the light, we can see that chair. Everybody in the room can see that chair because the light rays starting from the source of light, when it falls on the chair is going to reflect the light in all possible directions. So as we are sitting in the room in all possible directions, those reflected light rays enter into our eyes so that we can see that chair. So reflection plays a very important phenomenon in our daily life. So if reflection was not there, we were not able to see the objects around us. So this is a very important concept. So maximum, where does the reflection happen? Where does it happen? So usually we want to get our clear image. For example, if you stand in front of a highly polished metallic surface, we can see our image no doubt in that, but that image is not 100% clear. If you stand in front of, if you look yourself on the surface of the water which is still, you can see your image, no doubt in that, but that image is not 100% clear. So I want to see my image which is 100% clear. It should be so clear that I can see the minute things on my face. So if that is to be done, then we have to make a surface which is highly smooth and highly reflective. It should be smooth and highly reflective. So for that purpose, we use mirrors in our homes. So in our dressing tables, we have mirrors. We sit in front of the mirror, right? We can see our very clear cut images we can see. So when you go to very big malls or some shops, you can see very big mirrors put up there. You can see your images in that. So how these mirrors are made and what is the purpose? The purpose of making mirrors is to get 100% clear images. So how this mirror is made? So usually the mirrors what we have in our homes are nothing but they are called as plain mirrors. They are just plain mirrors. Why we call it as plain mirrors? Because they are not curved mirrors. So curved mirrors, in the next classes I am going to discuss that there are concave mirrors, there are convex mirrors which are not plain mirrors. So you will be having a thin glass slab. In case of a plain mirror, you will be having a very thin glass slab. On one side of the glass slab, if this is the glass slab, on one side of the glass slab they will paint silver, because silver is having the capacity of reflecting 100% light rays falling on it. So therefore silver is the best reflector of light. So they take a glass slab, that is a small glass plate. So because glass plate is transparent, because it allows all the light rays to pass through it, therefore I select a thin glass slab, and I will coat paint on one side. One side I am going to coat silver on that. First layer will be silver, because it's a highly reflecting, as it is having a highly reflecting property. So as silver can be easily scratched, it can easily remove from the glass. So therefore, to protect the silver on the glass slab, we are going to paint it red. So when you see from this side, we can see our image which is formed. So this is how mirrors are made. Usually when they coat low quality silver on the glass plates, they get worn out. So maybe in your houses you can see some old mirrors where some dots are formed, some brown color things are formed. You cannot get your really correct images on it, because they are not reflecting the light rays falling on it. So therefore they have become old, they cannot be used. So when you replace that by a new mirror, so it has 100% silver coating on that, and it is protected by a red paint on it. So you can get a very clear cut images, right? So here usually what we do is, a plane mirror is represented by a straight line. Usually in the optics we do it. So this is a plane mirror where one of the side is rough surface. In the sense, if this is the glass plate and you have coated silver and you have painted red on it, then this surface will be the rough surface and this side will be the smooth surface, right? So here this side is the rough surface and this side will be the reflecting surface. Right? So this side is reflecting and this side is rough surface. So when a person stand here at this point, if a a person stands at this point, he can see his image in the plane mirror. So this is what happens, right? So in a mirror, what happens is the distance at which a person stands in front of the mirror, the image inside the mirror will be at the same distance inside the mirror. That's called lateral inversion. So that property I am going to discuss at the time of the image formations in a plane mirror, and I will come into that. So while drawing ray diagrams connected to the mirrors, we use straight lines because light travels in a straight line. The ray of light is also represented by a straight line, but we put an arrow mark somewhere wherever you want. This arrow mark indicates in which particular direction the light rays is traveling. So the light ray is always represented by a straight line, and this arrow mark indicates in which particular direction the light rays are traveling. Right. So if there are more than one light rays, for example, in your bike you have the headlamp, when you start the bike and put on the headlamp, a beam of light rays is going to come out from that. You can see that beam of light rays. So many light rays which are traveling parallel to each other, right, or a bunch of light rays taken together is called as beam of light rays. This is called beam of light rays. Beam of light rays. So it's a bunch of light rays, thousands, crores together light rays. A bunch of it is totally called as a beam of light rays. So this is the beam of light rays, and this is a light ray. So while drawing ray diagrams, we do not use this as usually. We go with a ray of light. So remember this, a ray of light is always represented by a straight line with an arrow mark. Right. So next we will go with the very important property, that is how reflection happens in a mirror. So you can see that through a right. Okay. So we have made a small image for that. You can just look into that. So this is the mirror. So these are the incoming light rays. They fall on the mirror. This is the point at which the light rays meet the mirror. This is highly polished surface. So beam of light rays, they form wavefronts because they come and hit the mirror and form the wavefronts. And if you consider this as a ray, this is one of the ray and this is another ray we can see here. So this is how reflection happens. Once again, this is the incoming light path. So these are the light rays. They hit the surface of the mirror at a particular point. It is going to get bounced back here. So these are the wavefronts. So if these wavefronts are represented by straight lines, so this becomes another one light ray, which is incident, and this is the reflected light ray. Okay. Right. So before understanding more and more regarding the reflection of light, we have to understand certain technical terms which are related to reflection of light. So before that, let us go with all these four fundamental terms, and then we will go with the reflection, the law of reflections. Right. Okay. For example, consider this as a mirror which is rough at one end, and other is the reflecting surface. So upper surface is the reflecting surface, this is the reflecting surface, this is the rough surface, right? So here, imagine a light ray coming from a particular direction. So this is a light ray represented by a straight line, and I have put an arrow mark on this, so that represents that light ray is traveling in this direction and it is falling on the mirror. So here, the light ray which falls on the mirror or the light ray which travels towards the mirror is called the incident ray. This is called as the incident ray. Right. Next, the point at which the light ray meets the mirror. The point at which the light ray is going to touch the mirror or meet the mirror is called as the point of incidence. This is called point of incidence. So, okay. So after reflection, the light ray is going to travel in this direction. So this is the light ray traveling after reflection from the mirror. Therefore, this is called as a reflected ray. This is called as a reflected ray. So this is the incident ray. This point, let us call it as point O. This point is called the point of incidence, and this light ray is called as the reflected ray. Right. So now we draw a normal at this point of incidence. So this should be always a dotted line. So why this normal should be a dotted line? Because we have to differentiate this normal from the incident light ray and the reflected light ray. So therefore you have to represent the normal always by a dotted line. You should never call it as normal ray. Many of the students I have heard saying that, sir, this is normal ray. So it's not normal ray, it's just a normal. Right. So a normal is a dotted line drawn perpendicular to the mirror. Drawn perpendicular to the mirror at the point of incidence. So this normal is drawn at the point of incidence for reference. To check the directions of the incident light ray and the reflected light ray. So how they differ, in how their directions are differing, to analyze that we need a constant line. That constant line is always drawn perpendicular to the mirror at the point of incidence. Right? So once again, this is the incident ray which is moving towards the mirror. The point at which the light ray meets the mirror is called the point of incidence, and this is the light ray which is going out of the mirror or bouncing out of the mirror after reflection. Therefore, this is called the reflected ray, and this is the normal which is drawn at the point of incidence. Therefore, it is called normal. So just normal, not normal ray. So these are the 4 points you have to remember before understanding the laws of reflection. Right. So we'll go with the laws of reflection now. So, depending upon the property of light, we have ground its properties. We have ground its properties. In the sense, we have watched the properties of light. So, by watching the properties of light, doing a lot of experiments on that, we have come across 2 final conclusions how light behaves when they fall on certain highly polished reflecting surfaces. So, I want to repeat this. After performing various experiments on when a light ray falls on a highly reflected surface, how the light ray behaves. So depending on that, we have come across 2 final conclusions, and those conclusions are called as the laws of reflection. So these laws of reflection are obeyed by all highly polished reflecting surfaces, including all type of plane mirrors, all type of concave mirrors, and all type of convex mirrors. So in concave mirrors also laws of reflections are applied, in convex mirrors also laws of reflections are applied, in plane mirrors also laws of reflection applies. Right. So okay. So now go with the laws of reflection, which is very important. It will be asked in your exam for 2 marks. Okay. Let us consider a highly reflecting surface. Usually we take it as a mirror. So this side I am going to make it rough, indicating that it is silvered at one end, that is silver at one surface and reflecting surface at the other. So if you don't have silver, you can also use aluminium, because aluminium is also a highly reflecting, it creates a highly reflecting surface, right? So it's very important. So consider this as a mirror. So let us imagine a light ray coming from a source of light travels towards the mirror and it is incident on the mirror at a particular point. So let us call it as O, and let us call this as right, A. So OA is, or AO is the incident light ray which is coming towards the mirror. So O is called the point of incidence. So here the light ray is going to get reflected. So let us call it as ray OB. So here ray OA is the incident ray. It is the incident ray, and ray OB is the reflected ray. It is the reflected ray. So now we draw the normal at the point of incidence. It's not the normal ray, it is the normal at the incidence. So which is perpendicular to the mirror. So here we can see that the incident ray, the reflected ray and the normal at the time of reflection, they all lie on the same plane. For example, if you take this as the mirror, right, if this is the incident light ray, it travels on the mirror, it travels to the mirror, gets reflected, and it is going to bounce back in the same plane. That is in the same plane. That is, if you keep a paper here, the incident light ray travels on the paper, gets reflected at this point, that is point of incidence, and the reflected light ray also moves in the same plane. So here, normal also can be drawn here. So, according to the first law of reflection, the incident light ray, the reflected light ray, and the normal are all on the same plane. In the sense, the light ray, it travels, the incident light ray goes in this direction. After reflection, it's not going to go somewhere here. It's not going to come below the plane. It's not going somewhere here. So it travels on the same plane. The plane on which the incident light ray meets the mirror, in the same plane the reflected light ray also moves out. So here, that is the first law of reflection. So the incident light ray, the reflected light ray and the normal at the point of incidence all lie on the same plane. Just like in a carom board you move different pawns. They all move on the same plane. Something like that. The incident ray, the reflected ray and the normal lie on the same plane. Right? So this is the first law of reflection. Let us go with the second law of reflection, which is still more easy than this. Very important. So here, let us consider a plane mirror. So it is roughened at silver at one end, one surface, and the reflecting surface at the other. So let us imagine a light ray coming from some direction. Let us call it as light ray OA. OA is the incident light ray. So let us draw the normal at the point of incidence. Normal at the point of incidence. Now the angle between the incident ray and this normal is called the angle of incidence, that is represented by the small letter I. Always it will represent the angle of incidence by the small letter I. Next, the light ray after reflection from the mirror at the point of incidence, it is going to move in the same plane and goes out after bouncing back from the mirror. Let us call it as ray OB. So now, here OB is the reflected ray. Now, the angle between the reflected ray and the normal is called the angle of reflection, represented by small letter r. If you measure angle I and angle r, you will find that angle I is always equal to angle r. That is, the angle of incidence is always equal to the angle of reflection. So this happens for light ray falling on any highly polished smooth surface. This law is obeyed by the light rays. So this is the angle of incidence, this is the angle of reflection. This angle of incidence is always equal to the angle of reflection. So once again, first law, This is the first law of reflection. The incident ray, the reflected ray and the normal all lie on the same plane. So this is the second law. So second law states that the angle of incidence and the angle of reflection are always equal, or the angle of incidence is always equal to the angle of reflection. For example, sir, I will increase the angle of reflection. For example, here it is, I will take some 60 degrees, that is ray OP. Ray OP is 60 degrees with the normal. So what happens with the reflected ray? It is going to get reflected in the same plane, creating an angle of again 60 degrees. Let us take it as OQ. So here, angle between the incident ray and the normal is 60 degrees. Again, the angle between the reflected ray and the normal is again 60 degrees. So this shows that angle of incidence is always equal to the angle of reflection. If you decrease the angle, sir, I will make it just 10 degrees. Then also the reflected ray goes out, making an angle of 10 degrees. So if you increase the angle of incidence, the angle of reflection also increases in the same quantity to the same magnitude. If you decrease the angle of incidence, then also the angle of reflection decreases to the same magnitude. So therefore, first law states that the incident ray, the reflected ray and the normal at the point of incidence are in the same plane. And second law states that the angle of incidence is always equal to the angle of reflection. So now, angle I is equal to angle R. So this is the mathematical form of second law. So this law applies for all type of mirrors, that is including plane mirrors, concave mirrors and convex mirrors. So now let us see a beautiful animation, because I cannot show you light rays, because light rays cannot be seen. I cannot make you imagine to the depth, so therefore I have taken the help of the media here. Okay. So this is the source of light. The light rays are coming, falling on the surface of the mirror. They are getting reflected. So it's a scenario here. So this is the incident ray, this is the mirror here. It is getting reflected at this point. This point is called the point of incidence. So after bouncing back from the mirror, the light ray goes away. That is called the reflected light ray. So here you can see the dotted line drawn for the normal. So it is always perpendicular to the mirror. So angle of incidence is always equal to the angle of reflection. That is first law. That is okay. Now you can see the angle of incidence here. Incident light ray and the normal. So this is the angle of incidence here. It is represented by small letter I. This is the reflected ray. This is the normal, and this is the angle. It is angle of reflection. Angle of incidence is always equal to angle of reflection. Angle I is always equal to angle R. That's very important. I increase the angle value, I value is increased, so naturally R value also increases to the same magnitude. So here also again angle I is equal to angle R. So this is very important. You can imagine this. It's a very important concept. The incident ray, normal and reflected ray. You have to concentrate on these three. So this is the incident ray, this is the reflected and the normal. They all lie in the same plane according to the first law. So this is not possible. This is the incident light ray, and the reflected light ray cannot go in this direction. That's not possible. Violation of second second law, yes, it's not possible. Light ray cannot move in some other plane, cannot get into some other plane. Reflected light ray should be in the same direction, that is making an angle, same angle as I. Okay, so let us move on to the next concept. So next is very important. We have a plane mirror. Just imagine we have a plane mirror here. This is the silver surface and the other one is the reflecting surface. Let us imagine a light ray is incident normally on the mirror. Normally on the mirror. Normally, why we use the word? Because a normal is drawn always perpendicular to the mirror. Therefore, light ray is also falling on the mirror. Normally means the light ray is falling on the mirror perpendicular to it, making an angle perpendicular, that is 90 degrees to the mirror. So, what happens to the light ray when it falls on a plane mirror perpendicular to it? So, this is very important because when drawing certain ray diagrams, find out the position of the image and the size of the image during the ray diagrams of convex mirrors and concave mirrors. We need this concept. At that point I will again recapitulate. So remember this, whenever a light ray falls on the mirror which is perpendicular to the mirror, that is called as normally to the mirror, then after reflection the light ray is going to bounce back in the same direction. So normal is here, we cannot see the normal because the incident light ray is travelling on the normal. So when the light ray falls on the mirror perpendicular to the mirror, that is normally, then it is going to bounce back to the same medium in the same direction. So now what happens actually, technically what happens here? So here this is the normal and the light ray is travelling on the normal towards the mirror. So therefore the angle between the incident light ray and the normal is 0, that is angle I is equal to 0. So according to the laws of reflection, angle I is always equal to angle R. So angle I is 0, therefore angle R is also equal to 0. So since angle I and angle R are both equal to 0, therefore whenever light ray falls normally on the mirror, it bounces back in the same direction. So this is what happens when a light ray falls normally on the mirror. Okay, now let us go with another concept. After laws of reflection, let us go with the types of reflection, that is regular reflection. Regular reflection and irregular reflection. Regular reflection or irregular reflection, also you can call it as diffused reflection. Diffused reflection, very important. Right, let us go with this. Now, in a regular reflection, what happens? Consider a smooth surface, which is maybe, let us take our mirror itself, which is silvered at one surface and the reflecting surface of the other. Imagine a light rays, a beam of light rays are falling on the mirror. A beam of light rays, as I told you earlier, a bunch of light rays or beam of light rays or more number of light rays taken together is called as the beam of light rays. So a beam of light rays are falling on the very highly polished smooth surface. So these light rays are exactly, you can see here, they are parallel to each other. That means they maintain a constant distance between them. So they are parallel to each other, right? So let us go with this light ray, which is having the one point of incidence here. So after reflection, it is going to bounce back to the same medium. Let us go with this light ray. This is the point of incidence. After reflection, it is going to bounce back to the same medium. Let us go with this light ray. This is the point of incidence. After reflection, it is going to bounce back to the same medium. So here, during the incidence of the light ray towards the mirror, they were parallel to each other. and after reflection also they are parallel to each other. So here this type of reflection is called as a regular reflection. So why a regular reflection happens? See, the type of reflection depends upon the type of surface what we are using. So here the surface what we have taken here, on this surface all the molecules or atoms, right, whichever you can take, molecules or atoms, they are all aligned in the same direction. In the sense, all the atoms on this highly reflecting surface are aligned in the same direction. Therefore, when our light rays fall on the reflecting surface, they bounce back to the same medium. So the reflecting light rays, that is the incident light rays, are also parallel to each other. The reflected light rays are also parallel to each other, because the surface of the reflecting surface, that is the reflecting object, on this the atoms or molecules are all arranged in the same direction. Therefore, regular reflection happens. So now, if you come for irregular reflection, the surface will be not a smooth surface or a highly reflecting surface. For example, this may be wood surface, or it may be a paper surface, or it may be a wall, whatever it is. It may be a cloth, something like that. So it's a irregular, that is, it's a rough surface. So whenever a beam of light rays are going to fall on this reflecting surface, right, these light rays, this is the point of incidence, these light rays are going to get reflected in different directions. They get reflected in various directions. So we can see that the incident light rays are parallel to each other, but the reflected light rays are not parallel to each other. So if in a irregular reflection, the atoms or molecules on the surface of this reflecting surface are not aligned in the same direction. Therefore, irregular reflection cannot happen. So we have some advantages for irregular reflection, and we have some other advantages for irregular reflection also. Both are important. So here, why regular reflection is important? So if a light rays, beam of light rays fall on a highly that is smooth surface, and they get reflected, and the reflected light rays are also parallel to each other, then it is called regular reflection. This regular reflection happens. If regular reflection happens, then we can get images of the objects. If the regular reflection do not happen, we cannot get the images. In the sense, here we can frame the images, here we cannot frame the images. So for example, as I told you in the introduction, here there is a big room, many people are there in the room. At the end of the room there is I have kept a chair. Everybody in the room are able to see the chair, because the light rays traveling from the source of light, when they fall on the chair, that gets reflected in as like irregular reflection. As the light rays are going to get reflected in different directions, people are standing in the room at different positions, so the reflected light rays enter into the people's eyes and they can see the chair. If there was no irregular reflection, we would have not able to see the objects around us. So irregular reflection in nature is very important. So next is regular reflection. You stand in front of the mirror, you are able to see yourself, right? You are so happy seeing yourself, right? So thanks to irregular reflection, because if regular reflection happens, then only we can see or frame, or the images can be caught on the screen. That's very important. So this is irregular, this is irregular or diffused reflection. Okay, let us see a small video on this. I hope you will enjoy it. So this is the reflecting surface, parallel light rays. Before incidence they are parallel, after reflection also they are parallel. So both lines are parallel here before reflection, and after reflection also they are parallel to each other. Therefore it is a regular reflection. Let us go with irregular reflection. So this is the reflecting surface. Oh, you can see here. the light ray coming from here, it goes in some other direction. Light ray, another light ray coming in this direction, gets reflected in this direction. Therefore, reflected light rays are going in some other directions. It happens in a wall, it can happen on a board, it can happen on a paper. This is irregular reflection. Very important. Yes, you can see this. This is a rough surface. All the atoms and molecules on this are not in the same direction. They are not aligned in the same direction. But there, all the atoms and molecules on its surface is aligned in the same direction. That leads to regular reflection. This is irregular reflection. So here, one of my students in the last year, maybe he asked a question, sir, whenever light rays fall on the rough surface, does the laws of reflection does not apply here? Something like that. So here laws of reflections apply. Here laws of reflections are not applying. Why he asked the question is, here the angle of incidence is equal to the angle of reflection. Here the angle of incidence is not equal to the angle of reflection. So here light doesn't mean that the light is not obeying the laws of reflection. It's obeying the laws of reflection, but due to the atoms and molecules which are aligned in different directions, irregular reflection happens. So that's no way connected to the disobeying of that is light rays, that is law of reflection. It's not like that. You should not take it like that. So actually, irregular reflection happens because due to the rough surface. There, regular reflection happens because due to the polished surface. In both the cases, laws of reflections are obeyed by the light rays. No doubt in that. Okay. So this was today's topic. I hope you enjoyed it. So we have covered very important topics here today. One is reflection, another is regarding mirrors, regarding incident light ray, reflected light ray, normal, and then point of incidence we have discussed. We have discussed regarding the laws of reflection, regular reflection and irregular reflection. So all the concepts are very important. So read the textbook. So today's highlighted point what I am telling you is read the textbook. Textbook is your Bible, Quran and everything. It's a holy book for you. So read the textbook, listen to the teacher, right? While reading the textbook, underline the terms which are very important, technical terms which are very important. Try to spell the terms, try to write the spelling of the terms when you are reading the textbook. That's very important. So apart from that, tomorrow also we will be going with the physics session, including mathematics. So in mathematics I will be starting polynomials. So that's also a very important chapter. I hope you enjoyed the session. Send your comments, subscribe the channel, right? Stay home, stay safe, keep learning. Thank you very much.